Alright, a couple people asked me to explain what was going on here, and yeah, this is levitation. Quantum levitation. And I'm using quantum in, like, the actual scientific sense, not quantum as in woo-woo magic excuse. No, this is an actual quantum phenomenon. What's going on? Well, those little squares are very powerful neodymium magnets. They're getting put on this metal sheet. The metal sheet is basically there just to hold them in place. They're being arranged into a track formation. The person in this video is just a big stickler in making sure that they're all lined up correctly. And since they're magnets, they have a magnetic field, and you know how magnetic fields work. They push against other magnetic fields. If you have like poles, then they repel. If you have unlike poles, then they attract. But a very interesting thing happens when you have a low-temperature superconductor coming into contact with magnetic fields. This is what you're seeing right here. That little puck is a superconductor, and it's getting chilled down to an incredibly low temperature with liquid nitrogen. Normally, magnetic fields kind of surround things. I'm vastly simplifying this, so like physicists don't come at me. This superconductor, however, is pinned to the magnetic field. In a way, the magnetic field is going through it. And so it stays in place. It levitates, stuck in that place in the magnetic field. If you tilt it, it'll stay tilted. If you change its position will just stick. And if you exert a force on it, it will follow the magnetic field, which is what it's doing on this track here. But it's still levitating. You could put stuff underneath it and it works just fine. As the superconductor cools down, it slowly loses this levitating property, and then you have to re-chill it to get it to do this again. And the reason why it's gliding so smoothly like this is because there's basically no friction. There's air resistance, I guess, but that's it. So yeah, this is real quantum levitation. This is a real scientific fact. There aren't a lot of practical applications because the superconductors need to be super cool, but who knows what we'll find in the future.